Okay, in this video, we're going to see if the sequence converges or not, and then we'll see if the series converges or not. So let's take a look right here. And it's always a good idea to come with an explicit formula to work with. So we'll see. Notice that we have 1, 1, 1 on the top, and we have 9, 6, 8. 9, 6, 4 on the bottom there. So it's not so clear. But if we look at from 1, 3, 9, we just multiply by 3, right? And then on the bottom, we have 4, 8, 16. That means we just multiply by 2. In another word, we just need to multiply by 3 over 2, right, to get to the next term. And is that so for these numbers right here? And the truth is, it is. When we go from 1 over 9 and multiply by 3 over 2, of course, the 9 and 3 will cancel. You have the 3 on the bottom, and 3 times this 2 on the bottom will give us the 6 on the bottom. And then we can keep going, multiply by 3 over 2, and we can go from here to here, right? So in fact, this is a geometric sequence. And let me just write this down right here for you guys. We can write down AN equals, and let me remind you guys the general formula. We need A1 times the common ratio, and then raised to the n minus 1 power. And this right here is the common ratio, namely 3 over 2. So we can just write down A1 is 1 over 9, and then the R is just 3/2. And we take this raised to the n minus 1 power, and there we have it. This right here is our geometric sequence. Well, to answer this question though, we have to take the limit as n goes to infinity of this, right? So we'll just check. In order for us to see if this converges or not, we take the limit as n goes to infinity of this right here, which is 1 over 9 times 3 over 2 raised to the n minus 1 power, like that. But notice the following. Right here, this is our R, and R in our case is 3 over 2. And this right here is bigger than 1. So that means this right here actually will be infinity. Whenever we have R to the nth power, and then right here you have the minus 1, doesn't really matter. You can fix the negative 1 exponent if you would like. But if this right here is a number bigger than 1, raised to the nth power, and when n goes to infinity, we get infinity. So in fact, right here, AN unfortunately diverges because the limit is infinity, because R is 3/2. Okay? Now let's take a look if we add up everybody from there. So this is a series situation. This right here is asking us to do 1 over 9 plus 1 over 6 plus 1 over 4 plus 3 over 8 plus 9 over 16, and so on, so on, so on. It might not be easy to see, but the truth is that these numbers are getting bigger and bigger because every time we multiply by 3 over 2, which is a number bigger than 1. So the next number is actually going to be bigger than this, and so on, so on, so on. And the deal is that eventually the term is going to be approaching infinity because we did the limit right there. So the truth is, when we add up all of this, let me tell you, this right here will be infinity. So in another word, this right here diverges. So I'll write this down. N goes from 1 to infinity. And perhaps let me just write that down for you guys. I will write down 1 over 9, parentheses, 3 over 2, n minus 1. This right here, it's called the geometric series because we're adding everybody up. Series is when we're adding everybody up. This right here, notice because the R is 3 over 2, which is bigger than 1. So this right here, I will tell you, this series diverges. You can argue it this way because the R is bigger than 1, or you can also say the following. You can also say this, or the series n goes from 1 to infinity of this series. This right here diverges by the test for divergence because we saw that, let me just tell you, because the limit as n goes to infinity of the AN, which is the one that we did over there, this was not equal to 0. So in fact, when we see this was not equal to 0, we can go right here and say it diverges right away. But this is the geometry series form for you, right? So that's pretty much the connection. All right, so That's it. And be sure you guys watch our other videos so you can see more examples on this. That's all.